Here's question number 5 from CBE 3. So it's just find all the rational zeros of the polynomial function. And there's f of x. Really important, the directions. It says if it has 3 rational zeros, determine the order from smallest to greatest. If it only has 2, then we'd put it in order from least to greatest and just put an NA in the third box. If it has 1, just put the first one in, put in NA in the other 2 boxes. So that rational part is really important, right? They got it underlined for you. Remember, rational means fraction. That means we're not looking for answers that have square roots or i's. Okay, we don't have to concern ourselves with those. So we're going to use that rational zeros theorem, which says I take the factors of the last number, right, plus or minus the factors of the last number, which is just 1, over plus or minus the factors of the leading coefficient, which is 2. So I get 1 and 2 are its 2 factors. So my possible zeros are either going to be 1 over 1, which is 1, or 1 over 2. So those are the only possible zeros. So now you need to see if any of those work. Right? We're not using a calculator for this. So without a calculator, I'm going to plug in just each of those zeros until I find one that makes it equal to 0. So let's try this. So I just plug in 1. See, this would be 2 minus 5 plus 4 minus 1. So 2 minus 5 is a -3. -3 plus 4 is 1. 1 minus 1 is 0. Hey, that was great. My very first try, I found one. Okay, now I have a choice. I can either keep going. I could plug in -1 and a half and a -1/2 and see which of those work. Or if I want to, I can take that, right, if 1 is a 0, that means that x minus 1 is a factor. And so I could do synthetic division and just take it out. So now we have to choose here. I think I'm just going to do synthetic division. So I've got 2, -5, 4, and -1. The 2 drops down, times them, times those, add those, times those. And we knew that was going to happen, right? We knew it went into it evenly. So now I'm left with, if I take out the x minus 1, because I know the 0 is 1, now I have this left over. Right? I know that times x plus 1, or x minus 1, sorry. Let me just fix that. So now I'm going to set that equal to 0, and that should give me my other 2 zeros. So let's see if we can get that. So I'm going to go factor it, right? You could use the quadratic formula too, I guess, if you wanted, but this one I think factors. So I think we're going to go, I think it's -1 and -1. Let's try that. That would be -2x. That'd be -1x. That gives us the -3x. So we got the right form. Set them both equal to 0. So I go 2x minus 1 equals 0. So I add the 1 over and divide by 2. Hey, that was one of my rational zeros up there, right? X minus 1 equals 0, so you add the 1 over. Hey, 1 wasn't, we did this one, so I got 1 again, actually, so 1 is repeated twice. So it looks like I got, my zeros are 1, 1, and a half. Now we just want to make sure we enter it in correctly. Does it say what happens if we have a repeated one? There are 2 rational zeros. Carefully determine the order of the zeros themselves. All right, so I think what we're going to do is, because I wouldn't count those as different zeros, so let's try putting in a half and 1, and then we'll put NA in the third box. If that doesn't work, we'll try a half, 1, and a 1, and see if that works better. Let's give it a try. When we pull up the actual problem here, we'll enter this in. So we want a fraction, we want a half, and we want 1. Then let's just try putting it in NA. If that doesn't work, we will try it. We will try it. Man, that seemed to work good. I'm not sure. Maybe it would have worked if I would have put 1/2, 1, 1 also. But anyway, should be good there. So just remember, if it's a rational 0, okay, the important thing, if it's a rational 0, then you can use the rational zeros theorem. It has to be in this list. So I didn't have to do synthetic. I could have just tried all these numbers. I could have plugged in 1, and then -1, and then a half, and a -1/2, and just tried them until I got done there. The tricky part is 1 was a factor of twice, and so sometimes that's easier. Just if I find one that works, take it out. You know, we did synthetic division there, down there to take it out, And then you can just solve the leftover equation to find the other solutions.